Good morning, everyone. Today we will study the double sided surface carrier. So first we'll learn how to generate any double sided surface carrier signal, and then we'll study about the waveform. Okay. So in case of double sided, in case of AM waveform, we get the expression as ST equal to EC cos omega ct plus m EC by 2 cos omega c plus omega m t plus okay. So that means in this case, this is unmodulated carrier signal, and there is no relation between the message and between the message, which conveys no information. Okay, so if we omit this thing, then the total power will be reduced. Total power of the signal will be reduced, and no information will be lost. Okay, so that's why double sided surface carrier was introduced. Okay, so if we omit this thing, then this part is cos omega c plus omega mt and cos omega c minus omega mt. Now, if we multiply these two types of signal, that is, then we may easily get the double sided surface carrier signal. Okay. So considering the carrier signal is CT equal to EC cos omega ct and message signal MT equal to EM cos omega mt. Okay. So if we multiply these two signals, then we may easily get the double sided surface carrier signal. What is the advantage for this expression? Okay, this generates the carrier power, okay, which is very much higher, and that is basically wastage of power. Okay, that is no, it conveys no information. No information and wastage of power also. So same thing, if we get easily the information with less power, that will be obviously advantage for the system. Okay, and also it needs lower cost than that of AM signal. Okay, so if we multiply these two signals, so in case of double sided surface carrier, the carrier signal appears double. Okay, and it follows the envelope of the message signal that appears double. Two sideband appears, and the carrier signal is suppressed within the modulating signal. That's why it is known as double sided surface carrier. So we have drawn one message envelope, and similarly at 180 degree phase shift, we draw another envelope. Okay, so that we can generate the waveform. One important thing is that whenever the message signal crosses 0, okay, at that time we have 180 degree phase shift. We get 180 degree phase shift because of DSDC output. So again it crosses 0, then it happens 180 degree phase shift with that. Okay, so from this, so that's the we can generate that DSBC output. Okay, that's the one. And if we observe about the Fourier transform, then we have similar. Here we have we get two side band, that is at omega m and minus omega m. Similarly, if we get the Fourier transform of the carrier signal, then we have this one at omega c and minus omega c. Okay. Now, in case of DSBC output, since the carrier signal is supposed to be the modulated signal, and we have omitted the unmodulated carrier. So carriers, so carrier spectrum is absent here. Okay, and with respect to carrier signal, carrier spectrum, the sideband, two sidebands spectrum appears. Okay, this is at LSB, it is at USB, it is at omega c plus omega n, and at lower side band it is omega c minus omega n, and it is omega c. Okay, so what will be the bandwidth of the DSBC signal? Bandwidth is upper side band minus lower side band omega c plus omega n minus of omega c minus omega n, that is 2 omega n. Okay, and earlier we have learned the bandwidth of the AM signal, that is double sideband full carrier signal, is also twice the omega n. Then what is the difference between these two? Okay, in case of DSBC, DSB-FC, the carrier spectrum was present there. Okay, but in this case it is absent. Okay. So what will be the power of the double sideband? So in this case, on total power, in this case the total power is nothing but the sideband power only, because carrier signal is absent here. So sideband, that is by 2. Okay, and how much power is saved from the AM signal? We may compare these two. So here we have equal to, we have that is when n equal to 1, DSB is just the one-third of AM power. Okay, that is the advantage of DSBC and DSB-SC compared to the AM. Just when at critical modulation, it needs only one-third of the total amplitude modulated power.